Okay, so this question of section B mentions that there are two thin lenses of same focal length f, but one is convex and another one is concave. When they are placed in contact with each other, the equivalent focal length of the combination will be equal to what? We know that the convex lens is a converging lens and concave lens is a diverging lens. Why? Because their refractive indexes are more than the outside medium. Now, if the focal length of both the lenses are equal, the power of both the lenses will be equal but in opposite sign. So if some parallel rays of light falls on the convex lens, it will be, of course, it will be converged, but that ultimately convergence will be cancelled by the concave lens, and rays of light will go undeflected. Thereby the focal length of the combination will be equal to infinite. We can also do it like this. We know that the focal length of combination is equal to 1 by f1 plus 1 by f2. For convex lens it will be, let's say, f, and for concave lens it will be minus f, so this will be equal to 0. Thereby 1 by f is equal to 0, which means f is equal to infinite. Let's move on. Here in this question, the net impedance of the circuit is something that we have to calculate. So let's write down the data. First, L is equal to 50 divided by pi millihenry, and then the capacitance is given 10 power 3 pi microfarad, and the resistance equal to 10 ohm, and we are supposed to calculate impedance. Well, when we attempt to calculate impedance, what do you mean by the impedance? Here we have to calculate the magnitude of impedance, which means we have to calculate this quantity Z mod, which is equal to square root of r square plus xl minus xc whole square. Let me calculate this xl and xc respectively. Here in this question, the frequency of the source is given to be 50 Hz, which means the angular frequency will be equal to 2 pi multiplied by f, which will be equal to 100 pi. Let's calculate xl. So xl will be equal to L omega, or omega L. It is equal to 50 pi into 10 power minus 3 multiplied by 100 pi. So this pi will be cancelled, and then 5000 multiplied by 10 power minus 3, so this will be equal to 5 ohm. On the other hand, xc will be equal to 1 by omega c. Let me put the value here as well. 100 pi multiplied by 10 power 3 by pi multiplied by 10 power minus 6. Again pi cancelled. This will be 10 power 5 into 10 power minus 6, so this will be 10 ohm. Let me put all the values here. So this will be equal to 10 square, then this will be equal to 5 minus 10 whole square. So 100 plus 25, it will be equal to 125. So answer will be equal to 5 square root of 5. Option 3. Let's move on. Here in this question, the ST graph of a particle performing simple harmonic motion is mentioned, and we are supposed to calculate the acceleration of the particle at time t equal to 0. First of all, if I look at the graph, it's very simple displacement. The displacement of the executing particle is very simple. It's a sinusoidal. It will be like this, and corresponding to this particular displacement, what will be our acceleration? We know acceleration will be equal to minus omega x square. What is this omega? I'm sorry, minus omega square x. What is this omega? Omega equal to 2 pi divided by t, where t is the time period. Well, from the graph I see that the time period is 8 seconds. Therefore I can write 8. Therefore, if I put the value of this particular omega, and then I need this value, the corresponding displacement. But since I have to calculate acceleration at t equal to 2 seconds, therefore I will look at the displacement at 2 seconds. So at 2 seconds the displacement is this one, 1 unit or 1 meter. So this will be equal to pi square by, this is 4, 16. So 16 pi minus pi square by 16 meter per second square. Let's move on. Here it is given that an electric dipole is placed as shown in the figure, and we are supposed to calculate the electric potential at point P. So we will calculate the electric potential due to each charges, first due to plus charge and then due to minus charge individually. Both are point charge particles. For first one, the constant 1 by 4 pi epsilon naught charge divided by the distance. Well, from the center to the point distance is 5, but since I am writing the electric potential due to this particular charge q, therefore I will write down this one as 2 centimeter. For the next one, it will be equal to minus q k, and then this is 3 plus 5, which is equal to 8 centimeter. So kq 2 minus kq 8 into 10 power 3 to 10 power 2. Therefore this will be equal to 8 4 kq minus kq into 10 power 2. So this will be equal to 3 by 8 kq into 10 power 2. So that's the answer, option 1. This question says that a bullet from a gun is fired on a rectangular wooden block with a velocity u. That means when it enters, that time the velocity of the bullet was u. When bullet travels 24 centimeter through the block along its length horizontally, then velocity of the bullet becomes u by 3. Then it further penetrates into the block in the same direction before coming to rest. So what is the total length of the block? That's the question. Well, the scenario is like this. So when the bullet enters, then the velocity was u, then it goes up to certain, let's say this is a, this is b. At this point the velocity of the bullet is u by 3, and then it goes further, and this is the point where it stops, and this is in fact the end point of the wood. Let's say that point to be C, and at this point, since the bullet stops, the velocity will be 0, and we are supposed to calculate the total length of the block. Well, throughout this particular exercise, I assume that the acceleration of the bullet is equal to constant, some constant. So first I will apply the equation of motion between A and B. So what sort of equation of motion I will apply? Let's say the third equation of motion I will apply, where time is not involved. So according to that, final velocity square equal to initial velocity square plus 2 acceleration multiplied by distance. Well, this distance is 24 centimeter. So this is 24 centimeter. Keep it as centimeter. So this is u square by 9 equal to u square plus 2a multiplied by 24 centimeter. If I take this u this way, so this will be equal to minus 8u square by 9 2a 24 centimeter. Keep it equation 1. Now I will apply in the second case the equation of motion between B to C. In that case, what happens is that the final velocity becomes equal to 0, and at B the initial velocity is u by 3. So this is equal to 2a, and this is the distance that we don't know. This is the distance that we don't know. We can also do the same problem by applying the equation of motion between A and C. So that also we can do. It will give us the result a little early. So this will be equal to u square equal to minus 2as. So I can put this value here. So minus 8 by 9 multiplied by, this is 2as, this will become plus, this will be 2a multiplied by 24 centimeter. This 2a will be cancelled. This is, let's say, x. And if we solve little bit, let's say here I'm solving 9 by 8 multiplied by 24 centimeter. So this will be equal to 27 centimeter. So answer is option 1. Let's move on. So here in this question, there's a combination of lenses. According to the question, the two plano concave lenses, and they basically sandwich one convex lens according to the description given in the question. And we are supposed to calculate the equivalent focal length of this combination. Let's consider this is lens 1, this is lens 2, and this is lens 3. Since lens 1 and lens 3, they are identical, therefore the focal lengths of both of them will be identical. So for lens 1, what will be our focal length? So 1 by f1 will be equal to the refractive index 1.6 minus 1. I am applying the lens maker's formula here. This is equal to first surface, this will be equal to infinity. Second surface, it will be equal to 20. Thereby it will be equal to minus 0.6 divided by 20, 1 by f1. Therefore, for the lens number 3, the focal length will be also same. It will follow the same relation. Now come to the convex part. So here in this case, let's say focal length equal to f2, and thereby I will write down the refractive index, and then since it is biconvex lens, this will be 20, and for R2, since it will lie on the minus x-axis, it will be minus 20, and 0.5 multiplied by this, ultimately it will become 1 by, or simply 1 by 2 into 2 by 20, 1 by f2. So 1 by f2 will be equal to 1 by 20. So the focal length of the combination will be 1 by f1 plus 1 by f2 plus 1 by f3. 1 by f1 and 1 by f3, they are same. Therefore, this will be equal to 0.6 minus 0.6 by 20. Then this is 1 by 20 minus 0.6 by 20. So this is 1.2 into minus 1.2 divided by 20 plus 1 by 20. So this will be equal to minus 0.2 by 20. So this is the focal length of reciprocal of the focal length of combination. So I take the reciprocal, this will become 0.2. Let's simplify a little further. So this will be equal to minus 100. So option 3 is the correct one. So this is logic gate question. Logic gate question, we will try to identify what kind of gate is this and what is the operational formula for this output. First of all, this is AND gate, this is NAND gate. So here output will be A bar, here it will be B bar, and then what will be the output here? Our inputs are A bar and B bar. So product, since it is NAND, we have to take one more complement. Now I will apply De Morgan's formula, and then I will break the upper part of the complement, and it will become equal to A plus B. So Y equal to A plus B is nothing but the OR gate. So which one is showing OR gate? So I think this one is showing OR gate. 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 equal to 1. So this is the answer. A horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upward with a velocity of this one. The ball strikes the water surface after 4 seconds. What is the height of the bridge above the water surface? Well, let's say this is the bridge, and from this particular point, a ball is released or projected. When ball was projected, it was given certain velocity in the upward direction. That time the initial velocity was equal to 4 meter per second. 4 meter per second. Or I will, if I draw it nicely here, little nicely, initial velocity equal to 4 meter per second. It will go up and it will strike the ground after some time, and we are supposed to calculate this height. I will consider upward direction to be positive, downward direction to be negative. So when ball's initial position is this one and final position is this one, so displacement is downward, I have to consider it to be negative. Now in this case I will apply the equation of motion. So s equal to ut plus half of at square. So displacement minus velocity 4, time given to be 4, acceleration due to gravity is always minus because it is downwards, so this is 4 square minus, so this is 16, 10 into, this is 16 minus 4, 16, and this is 4, this becomes equal to 40. I think I made a mistake here, so this is 10, this will be equal to 2, and this is 8, so this will be 80. So ultimately it will be equal to minus 64, so answer is 64. This question tells that there are 10 resistors, each of resistance R, they are connected in series with a battery of EMF E and negligible internal resistance. Then those are connected in parallel to the same battery, the current increased n times. What is the value of n? Well, there are 10 resistors according to the question, and the current relation is given. So current equal to net EMF divided by the equivalent resistance. So in the first case, all the resistors were connected to battery in series, therefore it will be equal to 10 times R. In the second case, all the resistances were connected in parallel. So since they were connected in parallel, this will be equal to R by 10, and that time the electric current becomes n times the original one. This is the second case. So what is the value of n? First of all, we will put the value of I. So I's value will be E by 10R. So this will be equal to E. This 10 will go up. So ER will be cancelled. So n will be equal to 100. Let's move on. So 100 is the answer. Here in this question, the magnetic field is given, and it is mentioned that there is an electric wire which carries currents, some current I. The L length of the current element is I multiplied by L, and this current element, the direction of the current element is along x-axis. X-axis means this I cap is the unit vector, and the magnetic field is given here. So we have to calculate the magnitude of force. Well, magnitude of force, since it is everything is given in vector form, so we will use this formula. Well, so we have to take the cross product. Let's take the cross product. So what is this L cross B? All for the moment, let's say I L cross B. This is I cap, J cap, and this is K cap. This will be equal to I multiplied by L. This is 0, 0, 2, 3, and this is minus of 4. Let's calculate. For X, everything will be 0 because these two quantities are 0. So for Y, for minus J, it will be equal to minus of I multiplied by L, then multiplied by 4, then it is 0. For K again, it will be equal to 3IL. So this is equal to 4IL J cap plus 3IL k cap. So that's the amount of force, but the answer is mentioned in terms of magnitude. So what is the magnitude? So magnitude, we will calculate it like this. So 4il whole square plus 3il whole square. 4 and 3, when we use it in the Pythagoras theorem, it becomes 5. So that's the answer. A satellite is orbiting just above the surface of Earth with a period of t. If d is the density of Earth and g is the universal gravitational constant, what does this quantity means? So it is talking about the time period, satellite, density. So simply I will write down the time period, expression for the time period. So expression for the time period is equal to this one for a satellite, where this smaller is the radius of the orbit of the satellite. But since it is mentioned that the satellite is revolving just above the surface, it means that the radius of the orbit of the satellite is approximately equal to the radius of the Earth. Let me square both sides. 4 pi square. Write down here r cube gm. Now, since this question is mentioning density, I will convert this particular m in terms of density. How? We know that mass is nothing but volume multiplied by density. Volume is equal to 4 by 3 pi r cube and density is d. So this is r cube cancel, 4 pi will be cancelled. So this will be equal to 3 pi divided by g d. So answer is option 2. Here in this question it is mentioned that there's a body, and this body is, let's say, is placed in a particular car, okay, on the floor of a car, and this car is, let's say, moving. Now when the car is moving, it will move with a certain acceleration, and thereby some kind of pseudo acceleration or pseudo force will be applicable to this particular body. Now in this case the body has the tendency to move backward, but because of the friction it cannot move backward. So what can be the maximum possible value of coefficient of friction, which is called the static friction, coefficient of static friction, so that the body does not move, okay, it remains stationary? First of all, let's say the acceleration, I'm sorry, we have to calculate the acceleration of the car acceleration of the car so that the body does not move. Let's say the acceleration of the car is a, thereby the pseudo acceleration will be a. Now the resultant force or the force on this particular body due to pseudo force will be ma. This is not the resultant force, by the way. Now since it has the tendency to move in the backward direction and the friction is preventing, it means the friction will be this way, and body is placed on the horizontal plane, therefore the friction will be equal to mu multiplied by normal force, which is for in horizontal plane mg. So for maximum acceleration, this ma should be equal to mu mg, or acceleration will be equal to mu multiplied by g. So mu is 0.15 multiplied by this is 10. So answer is 1.5. In this question, there is a resistance, platinum resistance. Let's say this is the resistance. Initially the temperature of this particular piece of resistance was 0 degrees centigrade, and then the temperature is raised up to 80 degrees centigrade, and we are given to understand that initially the resistance was equal to 2 ohm, let's say R1, and then the resistance becomes equal to 6.8 ohm. And under this situation we are supposed to calculate the coefficient of resistance of this particular wire. It's a direct formula. So R2 equal to R1 multiplied by 1 plus alpha. So this is 80 minus 0. Let's put the value. Final resistance equal to initial resistance 1 plus alpha 80. So this is 3.4 equal to 1 plus 80 multiplied by alpha, then this is 2.4 equal to 80 alpha, and then alpha will be equal to 2.4 divided by 80. Therefore, if I write it like this, 24, so this is 8 into 10 power 2, so this will be equal to option number 3. This question says that radius of the innermost orbit of the hydrogen atom is equal to this one, which is also called the Bohr radius. So this is equal to 5.3 into 10 power minus 11 meter. We are supposed to calculate the radius of the third orbit. So we know that radius is proportional to n square. So this will be equal to 3 square multiplied by the corresponding value, 5.3 into 10 power minus 11. So 9 into 5.3 into 10 power minus 11. So 9 into 5 is 45. So nearest answer is this one. This is the last question. It describes that a very long conducting wire, very long means we have to consider infinitely long. It is bent in the shape as given in the figure, and we are supposed to calculate the magnetic field at point P. So how many structures are there? Two long straight wires are there, and we have one semicircular arc, and we will have to calculate the magnetic field, magnitude of the magnetic field. First of all, due to this semicircular arc, the magnetic field will be coming out of the board. What will be that? That will be equal to mu I divided by 4r, because it is semicircular. How it is coming out of the board? By applying right hand cross rule, and both magnetic field due to both the straight wires will be in the downward direction. Okay, so net magnetic field will be B1 minus this combined magnetic field of both of them, which will be in fact equal. Now this will be equal to mu I divided by 4r, and this is, since both will be equal, how? This will be equal to mu I divided by 4 pi multiplied by r, let's say into 2. So this will be equal to mu I divided by 2 pi r. So when I take common, I can see that this pi term will be at the last, and it is coming out of the board, so answer will be this one. Thank you very much.